find the decimal form of 15/8. Divide, absolutely, you divide. So, 15/8 means literally 15 divided by 8. So we're going to take 8 into 15. By the way, calculator is required for this class, and you are almost always allowed to use it, including now. So if you're saying to me, I don't want to do long division, I'll say, okay, get your calculator out and do it that way. I don't want to do long division, I'll get my calculator out and do it that way. 1.875. That's called a terminating decimal. Do you know what I mean by a terminating decimal? A what? It ends. It's a decimal that ends. Let's look at the next one. -11/6. So on my calculator, I will take -11 and divide it by 6, and I get -1.8 with a whole bunch of 3's going on forever and ever off the screen. That is an example not of a terminating decimal. This is a terminating decimal. This is an example of a repeating decimal. And any number that is either terminating or repeating is called a rational number. Have you heard that word before? Yeah. Rational. And the opposite of rational would be irrational. And those are numbers, now they're the opposite of this. So what do you know about irrational numbers? They don't repeat and they don't terminate. Ethan, you're right in the sense that if it can be written as a division, as a fraction, it's a rational number. Irrational numbers cannot be written that way. Irrational numbers, anybody give me some examples? What are some examples of irrational numbers? Pi, most famous one probably is pi. When you studied your logarithms last year, anybody quivering and twitching when I talk about logarithms? We talked about logarithms last year. Remember the ln? That's the natural logarithm, and its base is e, which is another irrational number. All of the non-reducible or whole number radicals, like root 2, root 13, root 27, those are all irrational numbers. They do not repeat and they do not terminate. It is one of the most amazing things. Last year, when I was completely bald, a friend gave me this scarf, and if you look closely at this scarf, what is that? Yep, the digits of pi are on this. Pi does not terminate, does not repeat. Look at all of those digits. Can you even believe it? It goes on forever and ever. Amazing. Amazing. Okay, next. Describe and graph. What is this talking about? Can somebody describe that to me? What is that? What does that say? If you were talking to your friend on the phone, how would you say that on the phone if he or she couldn't see it? What would you say? X is greater than 3. X is greater than 3. When I say graph it on the number line, how does that work? Open dot at 3. Now kids, I don't know where you're at with all this, but you no longer have to put a 0 on your number line and count. Just put 3 up there, whatever number you want. You don't need to have it all counted out and everything. Whatever numbers we're using, just Now what? There's the 3 with an, oh, by the way, why is that dot open?
It's not equal to.
Because it's not or equal to. This means open. This means closed, right? Alright, then what? Shade which way?
Right.
Right. Because this says greater than, and greater than is to the right. Also, as long as your X is first in the inequality, whichever way it's pointing is the way you shade. So it's pointing to the right, we're going to shade to the right. Alright, how about this one? What's that going to look like? It says describe and graph. What does that look like? What's the description? What are we talking about? All the X's where? Bigger than -4, but less than or equal to 2. So here's -4 and here's 2. What kind of dot here? Open. What kind of dot here? Closed. And then what?
Shade in between.
In between. Very, very good. Now, while we're here, the next problem is written differently, and I need to make sure you know what to do. This inequality, as you take your upper math classes, you see less and less of this, and more of what we call interval notation. Did you do that last year? This would be written like this. So there's the -4, and there's the 2. Notice there's a parentheses around the -4, and there's a bracket around the 2. Why do you suppose they're different? One's a parentheses and one's a bracket. Because one's an open dot and one is a closed dot. So the parentheses is the notation for the open dot, and the bracket is the parentheses for the closed dot. These two things mean the same thing. You all right?
Yeah.
You're about to break the world record. 21 minutes in and your head's already down. First day of school. All of these, or both of these, graph like this. Okay? So, when I look at the next problem, it says -1, -3, and it's in parentheses. Both of them. So what does that tell me graphically if it's in parentheses? That both -1 and 3 are open dots, and I shade in between. See how that works? It's real easy. And that is so much less writing than this. But they mean exactly the same thing. Okay. Can you do the next one on your paper there? Can you describe and graph this? What does that look like? See, take a moment and see if you can graph that.
How do you know you shade in between?
Okay, great question. This is called interval notation. Whenever you have two numbers separated by a comma, whether they are bracketed or parentheses or one of each, it always means start at the first number, start at the first number, stop at the second number, and include everything in between. That's just what the notation means. Okay, good question. You won't be using interval notation unless you're talking about everything between two numbers. That's when we use it.
Okay.
All right, so do you have this one done, kids? What did you do? I hope you have something going on at -2 and 6. I hope you have a closed dot at -2. Why? Bracket. I hope it looks like this, shaded in between. You with me? So if we have a quiz at some point in your future and I say draw this, everybody will draw this? All right. How about the next one? Tricky, tricky, tricky. What's going on here?
We're gonna have negative.
There's going to be a dot at 4. What about that dot? Solid dot. Wait a minute, but there's only one dot. So what do I do? Shade everything this way. Very, very good. So a minute ago, I told you that you were going to put 2 dots on the number line and shade between them. Sweetie, do you see the difference now when you put an infinity in there? As soon as you put that infinity in there, you're going to have an arrow. Okay? Now, how many of you remember solving a problem where you got an answer that was like this? You got a 2-part answer. Remember that? So on your number line, you had something that looked like this. Now, what would that look like in interval form? This is an interval right here. What would it look like, do you think? Any thoughts on that? What?
Would you use an infinity?
You would use not just one infinity, but you would use 2. And dang nabbit, we're going to have to save that for tomorrow. Oh, so much excitement, you probably won't sleep tonight. Have a great day. I will see you tomorrow. God bless you. Everybody's going to D.